for this circuit. Now let's try the same thing for this circuit. We'll start with the graph and the Euler's path, and let's start with the P structure. So this is your transistor A, H, A, B, D, sorry. So this, you have the P here, and let's draw a similar N structure. Let's name all these nodes. We have A, B, this is B, C. A and B are the same nodes. Since they're the same potential, this is node O. We'll name this node G. This we'll name it as X. This we will name it as Y. So you have transistor A, B, D, C, and E. Okay, and this is your node C. This is your node A. Since these two nodes are the same, they're represented as a single node A. This is node O. Okay, let's draw a similar N graph. So if we start with A, we have transistor B, transistor C, transistor D, transistor E. Sorry, these two nodes are not the same. So this is node X, this is node Y, this edge is your transistor D, this edge is your transistor E. Now we need to find the Euler's path. So if we start from V, we have A, we can go like this. So we can go to node C via edge A, then we go to node A via edge B. So we have A, B, then we can go through edge D, E, and C. So in this way we have covered all the nodes and the edges. Now let's see if we can find the same pattern for the N structure. So we can start with node G. We can go to vertex O via A. Then we can go to B, C, and then we need to go okay, so we cannot go, or we cannot have the same pattern that we got for P for N as well. So we need to think of something else instead of this pattern, or we will be sharing diffusions. So if let's start for the N structure first, then A, B, C, E, and D. Let's see if we can find the same for the P structure. So if we start with vertex V, we can go to vertex C via A, then we can have B, and then if we take the same path that we took for N, we will end here, and we cannot go to D any without lifting up N, so we'll get a diffusion jog. So basically this is not good as well, and we need to test every combination in this manner. So we have to basically get the same pattern for P and N structure. Okay, let's erase this. So this is going to take too long. So basically here you cannot have the same pattern, and hence you will get a diffusion jog. So if we have A, B, C, E, D, you can do it without diffusion jogs, but then your routings would change. You cannot have straight poly connections. Okay, I'll explain that in another video. For now, let's try to have the same pattern. So if we go from ABC, if we go through ABC, then let's take a diffusion jog for E and D. So we have A, B, C, and E and D will share diffusions, A, B, C will share diffusions. We can have a similar pattern for A, B, C, E, D for P and N with diffusion jogs. And this is the jog. We will get a similar structure for N as well. Okay, so you get the picture. Now you need to do the connections. You need to represent each of these nodes here. So since we started with A and then went to B, this becomes node B, this becomes node C, this becomes node A, this becomes node C again. Okay, for E and D, we can take either O or A. Let's take this as A. So you have O here and A here again. Okay, same thing for the N structure. This, if this is ABC, this becomes node G, this becomes node O. Okay, for the AH, this is G, O, this is your node X, and this is your node Y. Sorry. This is node X and this is node G again for the C transistor. If for E and D, if this is G, this is Y, and then this is O, and we need to basically connect all the O's and the G's, the C's, the A's. So this wraps up the video on how to do layouts. Thanks for watching.